Hello, honored to be here. I'm Shaoshan Liu from Perception. I guess today you have heard a lot of design talks and startup talk. Today I'm going to talk about how hard it is to do a real technology startup, and then what new technology would bring. For example, we work on autonomous vehicles and robotics, and then not just that it can free human from heavy labors, it can actually enable some new platforms to enjoy content. And then let's go into the details. A little bit about the background of the company and my background as well. So Perception's mission is to deliver affordable, reliable, and safe robotic mobility systems with computer vision. And then before founding Perception, I was with Baidu USA. We were doing heavy research on autonomous driving and robotics in the San Francisco Bay Area. Before Baidu, I was with Microsoft Research, Intel Research, LinkedIn, Broadcom, a bunch of other companies, about 10 years of industry experience. Before that, I got my PhD from UC Irvine. I got my business education from Harvard Business School. About Perception's investors and financials, we got our angel round from Warden International. Next, we got Matrix Partners, and then Samsung Ventures. In total, we got about $11 million of funding. So it's a fairly well-funded startup for the reason that technology is really hard and very expensive to do. First, in order to bring up such a startup, you need a very, very good team, very, very experienced team. Starting from advisors, we have 3 advisors, one for each area. Alan Wu, who used to be the CEO, the Senior Vice President for ARM Global, now is the CEO of ARM China, gave us a lot of advice from the industry side. Gary Bresky, the founder of OpenCV, gave a lot of advice for the computer vision side. Eventually, we are a computer vision startup. And then Jean-Luc Gaudiot, who's the IEEE fellow and then president of IEEE Computer Society, gave us a lot of collaboration from the academic side. So we actually need to integrate industry, schools, academic, and then computer vision into one piece to deliver this startup. And then regarding the team, our CTO is also a PhD from Tsinghua University, top school in China, and then experience with Baidu AI. Our COO, she got her MBA from Oxford. And then we have a chief scientist, also a PhD from America, UNC Chapel Hill, past experience with Uber, etc. So only if you have this very strong team, you can attract that amount of funding to enable us to do what we do today. So I'm going to talk about 3 things today that enables this company design. What is the design methodology that attracts customers, that attracts investors? What kind of products can we deliver under this design methodology? And then, the most important, what technology is behind this? Only with these 3 components, we can create a startup like this. First, design methodology. Most of you are coming from design background. But the talk itself is mostly technology-oriented. So hopefully, I can give you a crash course on autonomous driving and how we enable highly affordable autonomous driving. Because when we talk about autonomous driving robotics today, we're talking about Waymo, Uber, and so on. But the cost to bring up that kind of product, it's about $500,000 to $1 million to build up such a car. But with our design technology and methodology, we can bring up an autonomous vehicle within $40,000 US, and that's how. We break the whole design into modules. I'm sure I have a lot to learn from you. A lot of you are designers, but here's our methodology. We break it into different modules, and then it's like building a Lego. You put up the modules together to form this car. And then if you look at the modules, we have a computer vision module, we have a GPS module, we have what we call the passive perception module, radar, sonar, and so on, so that the car does not hit pedestrian and so on. Inside the car, we have what we call the planning and control module, which is the brain of the robot. So that's another way to look at it. We kind of break up the design into different components. We have computer vision, we have GPS, we have planning and control. Underlying it, we have the chassis, so the body of the robot. We have sonar, we have radar. By putting up these things together, we can create a car, and then by swapping any of the components, you can create your own autonomous robots or vehicles. Let's look at the details of how we create a active localization and computer vision system for the robot. So when we talk about robot or vehicle, there are only three things that we are talking about. The first of all, this vehicle or robot has to understand its environment. So if I'm a car, I need to understand what's in front of me, whether there are pedestrians in front of me so that I don't hit into those objects. The second thing I need to understand is where I am. You need localization. Just as you walk out on the street of Seoul, you need a phone with a GPS to guide your way. It's the same concept in robot and in car, so that we need a way to localize the vehicle. And then usually when we talk about localization, we use GPS, but sometimes, as you know, in this urban environment, your GPS signal gets blocked, then you need some other ways to do localization. So the core technology we have here is called sensor fusion, that we put up a bunch of sensors together, fuse the data to generate the result. That's one of our key products that enable this design. We have shipped these products globally to many different robotic customers, including Amazon Robotics and so on. So it's a camera-based design, similar to some of the startup that we heard before, except that for this design, it's designed for outdoor robotic environments to allow you to localize your vehicle and to perceive the environment, to understand your environment. So again, this talk is very heavy on technology, so bear with me, and then later on we'll talk more about the products that's generated from this technology. So here we see a street on Shenzhen, China. That's our testing ground. Using computer vision alone, this car can localize itself. It knows exactly where it is without a GPS, just like the human eyes that can understand the environment and use that information to help you find your location. The second part is called perception. How do you understand your environment? When a robot understands the environment, it's very different from how human understand the environment. It needs to extract specific objects from the environment, such as, for this example, there are several pedestrians crossing the street. What we need to feed the computer is that what are the objects that are crossing the street? How far away are these objects from me? How big are they? And then by combining these informations, we can do what we call the planning and control, or the brain of the robot knows how to go around the street and so on. So that's about perception and localization, or understanding the environment and understand where you are. A question I always get is, oh, okay, you use computer vision for perception. What if your computer vision miss an object? Would it hit someone? Would it crash into a wall and so on? Eventually, computer vision is not the ultimate solution. So we have several lines of defense. We have a sonar, we have a radar, what we call the passive defense, such that if it detects an object, the car stops itself to guarantee safety. Let's look at how it works. For example, in this case, we have a radar that can detect an area of about 15 meters. So if someone is crossing into this detection zone, the radar will pick it up, and if it's a human, it can track the human movement. If it's a car, it can track the car's movement such that it does not hit into an object. So that would provide a very high fidelity of safety for these kind of vehicles and robots. And that's how we guarantee that it's a safe vehicle. So as you can see in the rest of the talk, when we say we do computer vision-based robotic, we really mean a lot of different things. Usually a startup lives on one technology. We have to combine many pieces of technology into a whole product. That's why we need a lot of funding and resources to support these kind of activities. But also, I mean, these kind of activities will bring you a lot of profit eventually. The next thing we want to look at, I want to show you, give you an idea. Okay, you see the eyes of the robot that allows the robot to see the road and to perceive the environment. You see other sensors of the robot to enable it to sense anything that's in front of it. But there is a brain with the robot. The brain enables the robot to go around from any point on the campus to any other point to the campus, from your starting point to a destination. That's called planning and control. By itself, it's a very big field in technology. Here, we want to show you a very small demo, a video demo of my alma mater, actually UC Irvine campus. How do we have design brain for the robot? If we deploy the robot on a campus map like this one from point A to point B, how do we enable the robot to go around? That's actually the brain. We show it using a simulation. We thought that would be easier. Otherwise, you would not understand what is going on. So here on the top, we show the speed. We show whether there's an obstacle in front of the robot. And the robot just follows a route to go to its destination. If there's a car in front of it, what do? You follow the car if it's not blocking a path. But if there's something blocking a path, you go around it, just like how human drivers would do. At the end, after you reach the goals, you need to find the parking lot and park itself. Only with these functions, you can deliver an autonomous vehicle. That's how hard it is, and that's why it's so expensive to build these kind of robots and vehicles. OK, we kind of went through the design methodology. With a modular design, we can enable very affordable and reliable robots. When we did this startup at the very beginning, people would ask, oh, what's the end goal of this startup? Well, it's always to free human from heavy labor, right? Such as driving, we think it's heavy labor, especially in traffic, in heavy traffic situation. But then as we design more product, we think our end goal or mission kind of changed a little bit, because we figured that with AI, with autonomous driving technology, it can create a new field, a field that we never had before. So it creates new possibilities. So here's what we want to talk about, a new product enabled by this kind of technology. What about a vending machine, an advertisement machine that's mobile? If we can enable a mobile vending scenario, and then on top of it we put advertisement, it can really attract people. So pretty much from our experiment, we figured that mobility, it's a good attraction. It attracts attention. By doing advertisement on the body of the vehicle, we can convert that attention into what we call impression, just like how Google gives you an ad, that's impression. And then also by doing vending on a mobile device, or by mobile device I mean a vehicle like this, you can convert that attention into actual product sales. So we think that's a very good innovation, not just in technology, but also in business sense. So here's a very small video to demo the concept.
Percepton's Dragonfly Intelligent Advertising Vehicle offers turnkey solutions for mobile, robot, and autonomous driving scenarios. Using an innovative direct-to-consumer product vending system, the Dragonfly pushes consumers to engage with a customizable advertising screen space. With its state-of-the-art Dragonfly computer vision module, the vehicle is able to roam freely with satellite accuracy. No longer is conventional advertising tied down to billboards and stationary video screens. Now, your advertisements have wheels.
So when we brought up this model, people would always have doubts. Would this work? Why do you make it mobile? What does mobility bring? Somebody would think it's weird at the beginning. It's very hard for people to accept these kind of new innovations. So we did some experiments to tell you exactly why we make it mobile, what kind of features does mobility bring. So that's the first time we deployed this vehicle on the commercial complex in China. It does attract a lot of attention, tremendous attention. If you look at people's reaction to it, because they've never seen this before. You can think it's a gimmick machine, but it does attract a lot of attention. So we did a statistic. So within 15 minutes of operation, we try to see how many people we attract. It's 1,000 people, 1,030 people from the 4 different screens. And then the next question we asked is how many of these 1,000 people look at or stare at an advertisement for more than 5 seconds using conventional advertisement term. We think that's conversion or click-through rate using Google's term. It turns out it's really, really high. It's 58% CTR. A comparison is Google's online advertisement model. They give you impression, meaning that if you search on Google, they will show you a banner or page of advertisement. That's called an impression. The equivalent of impression here is the view that we show people. That's 1,000 impressions within 15 minutes. The second metric is called CTR. Once you see a impression, how often or how likely you click through that impression into the ad. Here, the equivalent is the attention more than 5 seconds. Oh, that's 58% here, but a normal Google ad is 2%. And then today, Google, Facebook still remain to be the most efficient way of online advertising. We just kind of convert that online advertising model to offline, such that with a mobile machine, you can give people impression, and then you can easily convert that into click-through rates or even buying activities with the vending machine. Next question we always get asked is, how do you know? How do you know that 1,000 people look at your screen for more than 5 seconds? Because we have this technology. We have a very small camera, a highly affordable camera that can track people's face to generate demographic information, such as what's your gender, what's your age, what is your emotion, and how long you stare at the screen. By using this demographic information, we collect feedbacks towards a advertisement, and we can generate that kind of report. If you look at the billboard today, even on the street of Seoul, you don't see this kind of feedback. Yesterday, I learned a new term. It's called smart signage. That's the first time I heard of that term, but basically that's what it is. You show people a sign, the sign displays an advertisement, and then you collect statistics of how often people look at it. And then based on the people's demographic information, you push different ads to this person so that the offline ads can be more efficient compared to online ads. And I think that's a huge innovation. We will see it coming. How does it work? So here is a very small demo. Edge device burns about 2 watts of power, connects to any Android or iPhone device. They can actually track people's facial expression and then tell how old that person is, whether it's a male, female, so that if you put that on a mobile vending machine or any signage, it can collect very strong feedback signals. And then by combining those feedback signals, you can actually generate very good advertisement reports. So what that tells me is that, well, it's a new kind of animal, if you would call it. It's a new kind of machine brought by this technology. But it's also a new platform for showing content. If we roll back to that video of that mobile machine, we don't know what's the best content for it. We can put up a Coca-Cola advertisement on top of it, right? Or you can put up some other advertisement on top of it. But we don't know exactly what's the best content for it. That brings another question. So if we were to deploy these machines everywhere in the world, what kind of content is the best fit? That's an open question. Actually, I think there would be a lot of innovation for this kind of space. We'll see. So now it moves to the very last part of this talk. What kind of technology is behind this kind of creation? How do we build up a technology barrier such that we remain to be the best startup in this space? Well, forgive me for the professional terms, but here's what we do. Usually, when we talk to VC or any other people who talk to VC, the first question they ask is, what's your technology barrier? Usually, it's one technology point. But doing what we do, we cannot rely on one technology point because the barrier is too thin. People can easily penetrate, especially with today's open source world. If people release some open source software, it might just break your barrier. So we have a lot of barriers to do this business. Perception is how you understand the environment. Localization technology, how do you use different sensors to localize the vehicle. Planning, how do you design and bring for the robots. At the end of the day, you have these independent technology. How do you integrate them into a system that can allow you to perform your computing all within the system? So you may know some of these terms, right? Semantic learning, which is deep learning. How do you extract label from a person? GNSS fusion, how do you rely on GPS and other sensors to give you a location? For planning, it's very hard. It's very professional terms. How do you, for example, behavioral planning, how do you have this vehicle behave like a human? And down here, I think Korea is very strong in this space. Embedded system, GPU design, and then we have FPGA integration. So if you count here, we have about 16 technology points to allow us to go into this business Remember, we are competing with Google, Waymo, and so on. So we have to integrate many, many different pieces of technology points. Another technology graph to show our technology stack. The first thing when we start a business is what's our usage scenarios, whether we have GPS enabled, what's the speed limit of the car, how's the lighting condition, and so on. If we go down, it becomes algorithm. What kind of algorithm is required to deliver this kind of performance? And then we go down to we have the operating system to allow us to do what we do. And then at the very bottom, it's what kind of hardware we need. So again, it's very in-depth technology. And then I'll skip that. That's a design of our system in its hardware. Very important thing when you're building a startup, what kind of patent you have, right? We always start with US patent, 2-year cycle. You submit the application. If everything goes smoothly, it doesn't get bounced back. It takes 2 years to get a patent to get approved. But usually the process is much longer because you have discussion with patent lawyers, with USPTO. So we have accumulated about 120 patents internationally, Korean patents, Japanese patents, Chinese patents, US patents, EU patents, and so on. And so we usually start with US patents, and we have a category of patents to protect our space. We start with one category, for example, computer vision for robotics. That's a new space. Usually it's empty. So as you build up your patent portfolio around a new space, you get a lot of protection. Say if Google one day figures out, hey, I want to do computer vision in this space as well, you cannot. You have to go around us in order to do that. So if you are thinking about doing a startup, make sure you have a full understanding of patent strategy. It goes a long way once you establish your patent wall, because that's one of your major barriers as well. I'm not sure how I want to do the deep dive, but let's go through it since we are already here. Well, first thing, to enable us to do what we do, we have done years of research. The team combined has over 100 years of industrial experience in robotics. So we have a lot of publication in different categories of technology. And then that's the basic of our technology. You have a camera. As the camera moves, you can actually tell where you are. So the camera also creates maps. With the map, you can localize yourself. So at any point in time, you know exactly where you are. I heard a few talks before this talk about AR, VR. One of the key technology in AR, VR is also this technology. You use a camera, and then as you move within the room, you create a map. As you create a map, you know where you are. That's how you track your movement in AR, VR. That's an example. As the car moves in space, it extracts a lot of what we call feature points from the space. And then these points allow you to localize your vehicle. So at any moment in time, you know exactly where you are. And that's the key technology we have. If we go into more details, we have a multiple camera system with what we call the inertial sensor. By combining the camera data and inertial sensor data, enable us to give you very accurate localization in real time. And that's our patented technology. I don't think anywhere else in the world you can find that because our US patent is granted for this kind of technology. So once we have a technology, we get asked a lot by different major companies, including, say, LG, Samsung, these leaders in this space. Okay, now you have your technology. How do you guarantee that the technology is leading in next generations of AI revolution and so on? We need to convert that technology into hardware, not just let it stay in software, because like I said, software evolves very fast, and eventually it's how you combine the hardware and software to enable you to do what you do. So the next generation product, what we call the Dragonfly Plus product, we kind of move all our algorithms into a piece of FPGA, such that the FPGA device will enable all the computing on the device instead of relying on, for example, NVIDIA's chips. This way we have full control. So using this design, our barrier is even higher. And then that's next generation design. A lot of details. We will not go through the details because it's a lot of technical terms, but the key message here is that we move all the algorithms into hardware. such that we control all the hardware, the algorithm, and the scenario. It's a vertical design. Once you build up a startup, you grow it vertically, it's safer. And then this slide just shows that our performance compared to the leading chip producers. For example, we compare to two chips, NVIDIA chip, which is GPU-based, and then Intel chip, which is Intel, right? It's the leading chip provider. So our chip, FPGA design, delivers 5x computing power compared to NVIDIA TX1 chip, 3x more power efficiency, meaning you burn less battery compared to TX1. We beat them in every single category by using. That's why we have a huge advantage. We are cheaper, more affordable design, and then we deliver much, much higher performance and burns less power compared to these leaders in the industry, NVIDIA and Intel. And then I will not go there, it's crazy algorithm, but that's how we create the map. But that's the math design, the math behind this design, if you wonder. So with this design, that allows us to do mapping as well. So I guess that's it. Thank you so much.